point, the topic for today, which is going to be matrix multiplication. On the previous video, we looked at scalar multiplication of matrix, right? But now we're going to be looking at matrix multiplication of matrix. So now let's take into consideration these two matrices. 1, 2, 3, 4, and let's say 3, 4, 1, 5, right? If I'm to multiply this matrix with this matrix, what am I going to do? What are the steps I'm going to take to carry out this multiplication? Now this is what you do. You multiply the rows here with the columns on this other matrix, right? You multiply 1 and 2 with 3 and 1. You multiply 1 and 2 with 4 and 5. Then you multiply 3 and 4 with 3 and 1 again. You multiply 3 and 4 with 4 and 5. Okay, so let's carry out this multiplication. Now we're going to have 1 times 3, right? 1 times 3 plus 2 times 1, right? 2 times 1. That's for this, multiplying this. Now, we're also going to use this same rule to multiply this column. So 1 times 4, we're going to have 1 times 4 plus then 2 times 5. 2 times 5. Now we've used this first rule to multiply the two columns on this matrix, right? Now we're going to use this second rule to multiply the two columns on this other matrix. So we're going to have 3 times 3 plus 4 times 1. Now that's for this times this. Now let's look at this times this, okay? Now 3 times 4 plus 4 times 5. So the resulting matrix is going to be, okay, 3 times 1, that's 3. 3, right? Plus 2 times 1, that's 2. Then 4 times 1, that's 4, plus 5 times 2, that's 10, right? So now let's look at this. 3 times 3, 9, plus 4 times 1, 4, right? 3 times 4, that's 12, plus 4 times 5, that's 20. So let's add these numbers together to get the final matrix. 3 plus 2, that's 5, 4 plus 10, that's 14, 9 plus 4, that's 13, and 12 plus 20, that's 32, right? So if you multiply this matrix with this matrix, this is what you're going to get. Remember the pattern we're following here. You multiply the row with the columns, right? You multiply this row from this matrix with the column on this matrix. That's like the pattern, the direction of the pattern you take. Let me throw light on something in my experience you might come across while you're dealing with multiplication of matrix. Now, you know from what we just said, to multiply two matrices, you have to multiply the row of the first matrix with the columns of the second matrix, right? So now let's look at this situation whereby we have two elements, like two rows here, two elements on this row, right? That is A and B. It could be a number 1 and 2, right? And then we have like 3 elements on the column here. That's E, G, I. It could be a number, right? 2, 5, 6. But I'm just using letters to explain what I'm saying. Now, you multiply the row with the columns, right? So I'm going to multiply A and E. That's A times E plus multiply B with G, right? That's B times G. Now, what am I going to multiply with I? There is nothing there, right? So take note of this. Whenever you want to multiply two matrices, the number of elements on the rows here, right, should be equal to the number of elements on the column here. If not, they are not going to be, commutable for multiplication, right? So this is a 2 by 2 matrix. This matrix here is a 2 by 2 matrix. And this is a 3 by 2 matrix, right? This is a 2 by 2 matrix. This is a 3 by 3 matrix. Now, since the number of rows here does not correspond with the number of column here, right? It's not going to be commutable for multiplication. Now, for the previous example we took, we had a 2 by 2 matrix and another 2 by 2 matrix. So since the number of rows and columns were the same, the multiplication was, we are able to carry out the multiplication there. Now, it's not compulsory, it's not necessary that the two matrices must be the same kind of matrix. That is 2 by 2 matrix, or another 2 by 2 matrix, or a 3 by 3, another 3 by 3. Right? Let me show you one possible scenario. Alright, so if this is Okay, now they are not the same matrix, but I think we can carry out multiplication here. This is a 2 by 2 matrix, then this is a 2 by 3 matrix, right? But since the number of rows here is the same as the number of columns here, we can still carry out the multiplication. Okay, so let's see if it's going to be possible. So this will be A times E, you know the direction, this going down. That is the row multiplying the column here. So this will be A times E, and this will be B times F, right? B times F, right? Then we use this to multiply this again. That's A times G plus B times H, right? You go here, you go here. Then finally, you still use A times B to multiply I times J, right? A times I, then B times J. After using the first row to multiply all the columns here, you can now use the second row to multiply the columns there. So this is going to be C times E. C times E plus D times F. Okay, so you get the point I'm trying to make here, right? The number of elements on the row here should be equal to the number of elements on every column here for the multiplication to be commutable, for the two matrices to be commutable for multiplication, right? So let's take one example on matrix multiplication. Okay, so we are going to look at this question finally on matrix multiplication, right? And the question says, if A, that's the matrix A, if A is 5, 4, 2, 1, and B is 3, 6, 2, 1, 0, negative 3, find I, A times B, right? A times B. Now let's find A times B. A times B, right? Let's find I, A times B. Now the matrix A is this 5, 4, 2, 1, right? Times, what's the matrix B? 3, 1, 6, 0, 2, and negative 3, right? So let's carry out the multiplication for A times B. First, let's see if it's going to be possible to actually carry out this multiplication. We have two numbers here, right? For the row here, and we have two numbers for every column here, so yes, it's possible. This one's going to multiply this one's going to multiply this, 2 and 2, so it's going to go. Now let's take down the multiplication. Now we're going to have 5 times 3, right? 5 times 3, which is 15, right? Plus 4 times 1, which is 4, okay? That's for the first multiplication. Now the second multiplication, we're going to have 5 times 6, which is 30, plus 4 times 0, right? 4 times 0, which is 0. Now, the third multiplication there, we're going to have 5 times 2, which is 10, right? Plus 4 times negative 3, which is negative 12, right? Now that's for the first row multiplying the 3 columns. Now let's look at the second row multiplying the 3 columns. We're going to have 2 times 3, right, which is 6, plus 1 times 1, which is 1. Secondly, we're going to have 2 times 6, which is 12, plus 1 times 0, which is 0. Then finally, we're going to have 2 times 2, which is 4, right? And 1 times negative 3, which is negative 3. So let's put all the answers together. Let's add up everything and get the final matrix. Okay, this is going to be 15 plus 4, right? Which is 19, right? 30 plus 0, which is 30. 10 plus negative 12. That's like saying 10 minus 12, right? 10 minus 12. So the answer is going to be negative 2, right? Now we are having 6 plus 1 here, which is 7. 12 plus 0, which is 12. 4 plus negative 3. That's like saying 4 minus 3, right? So 4 minus 3, 1. So this is the matrix we're going to get when we multiply the matrix A with matrix B. So secondly, we are looking at this question here, 2A times B, right? We are finding 2A times B. Now what's the matrix A? That's 5, 4, 2, 1, right? Times what's the matrix B? That's 3, 1, 6, 0, 2 minus 3. But now, since we have 2a here, like there is a scalar 2 multiplying a. The scalar multiplying a is 2, right? So before we proceed with the matrix multiplication of matrix, let's first of all settle the scalar multiplication of matrix, right? Okay, so we're going to have 2 times 5, which is 10, right? We're going to have 2 times 4, which is 8, right? We're going to have we're going to have 2 times 2, which is 4. We're going to have 2 times 1, which is 2, right? So now this is 2a, this is 2a, that is 2 times a. Now we can then proceed with multiplying this with the matrix B. Alright, so now we can proceed with the multiplication here. So we're going to have, the usual pattern, row multiplying column, right? So we're going to have 10 times 3, which is 30, plus 8 times 1, which is 8, right? Then we're going to have 10 times 6, which is 60, plus 8 times 0, which is 0. 10 times 2, which is 20, plus 8 times negative 3, which is negative 24. Right? And we're going to have, okay, that's for this first row multiplying all the columns. Now let's use the second row. We're going to have 4 times 3, which is 12. Right? Plus 2 times 1, which is 2. Then 4 times 6, which is 24. Plus 2 times 0, which is 0. You understand? Finally, we're going to have 4 times 2, which is 8, right? Plus 2 times negative 3, which is negative 6. Negative 6, right? 2 times negative 3, which is negative 6. So finally, what we have to do is add sum up everything and get the final matrix. Now let's do that here. Let's do that there. Okay, so 30 plus 8, that's 38. 30 plus 8, that's 38, right? 60 plus 0, that's 60. 20 plus negative 24, that's like saying 20 minus 24, right? The answer is going to be negative 4. Right? So 12 plus 2, that's 14. 24 plus 0, that's 24. 8 plus negative 6, that's like saying 8 minus 6, right? 8 minus 6, that's 2, negative 2, okay, positive 2. Okay, 8 minus 6, that's 2. Okay, so this is the final matrix. This is the matrix you're going to get when you multiply 2a with b, right? 2a with b. This is the matrix you're going to get. The third question here, that's I is b times a, right? Okay, we interchange them. We now multiply b with a, not a with b this time around. So let's see what the matrix b actually is. That's 3, 6, 2, 1, 0, negative 3, right? Multiplying a, and a happens to be 5, 4, 2, 1, right? So let's see if this multiplication can even hold in the first place. Now we have 1, 2, 3, 3 numbers for the row there, and we have 1, 2 numbers for the row here. So this multiplication is not going to happen, right? This matrix and this matrix, they are not compatible for multiplication, they are not commutable for multiplication. Reason being that if I multiply 3 with 5, that is 15, right? Plus I multiply 6 with 2, that is 12, plus what am I going to multiply this 2 here with? There is no number here, right? There is also no number here. Then we have 1 to 3, 1 to 3, and the multiplication we hold, right? So this multiplication cannot hold. So I think that will be all for matrix multiplication of matrix. Let's go to determinant of matrix. Let's look at finding the determinants of matrices. Alright, so before we proceed with determinants, take note of this. Only squared matrices has determinants, right? You can only find the determinants of a squared matrix. That's a 2 by 2 matrix, a 3 by 3, a 4 by 4, 5 by 5, and so on. You cannot find the determinants of a 2 by 3 matrix or a 4 by 5 matrix. It has to be a squared matrix. So I'm going to rewrite this as determinant of squared matrix. determinant of squared matrix. Okay, so let's start with finding the determinant of 2 by 2 matrices, right? We're going to start with finding the determinant of 2 by 2 squared matrix. So this is the first example here. This matrix A, let's say it's 2, 3, 4, 5, right? Let's find the determinant of A. Now, if the matrix is A, and this is the matrix, they represent the determinant by, this straight line bracket. Now, when you see these two lines guarding A or side by side with A, it actually means the determinant of A, right? So the determinant of A is going to be equal to this 2, 3, 4, 5. You can see these brackets are no longer the way they were, they are now straight lines, right? So let's actually find the determinant of A. For a 2 by 2 matrix, this is how you find the determinant. You multiply this as 2 and 5. So that's the right diagonal. You multiply the right diagonal and you subtract the left diagonal, that's multiplication. So let's do that. 2 times 5, right? 2 times 5 minus 3 times 4. Okay, so 2 times 5, we have 10 minus 3 times 4, which is actually 12, right? So the determinant of A is going to be the number -2, right? Okay, so that's the determinant of A, -2. Alright, so still on 2 by 2 matrices, let's take this second example, this second question. Find the determinant of the matrix W if W is actually equal to -4, 6, 5, and 2, right? So finding the determinant of this matrix, this is what we're going to do. The determinant of W, right? The determinant of W is going to be equal to this. The right diagonal minus the left diagonal, that's multiplication, right? So this is going to be equal to -4. -4 times 2, right? -4 times 2 minus 6 times 5. Okay, so this is going to be equal to -4 times 2, that's -8, right? And 6 times 5, that's 30. So we're going to have -8 minus 30. That's like -38, right? So the determinant of the matrix W is -38, right? -30, that's -38. Okay, so let's proceed to determinants of 3 by 3 matrix. Alright, so moving over to 3 by 3 matrix, we're going to solve this first question. Find the determinant of the matrix D if D is equal to 1, 2, 3, 4, 5, 6, 0, 2, 4, right? Now this is a 3 by 3 square matrix. Let's see how we're going to find the determinant of this 3 by 3 matrix. Now this is going to be a bit, complex than the previous 2 by 2 matrix. So let's find the determinant of D. Now this is the first thing you're going to do while finding the determinant of this 3 by 3 matrix. Alright, so you're going to assign signs, right? Positive and negative signs at the top of this first row, right? The numbers at this first row here, that's 1, 2, 3 in this case. You're going to assign signs to them, starting with positive sign, negative sign, positive sign, negative sign, positive sign, negative, and so on. That if you're having 5 by 5, 6 by 6, 10 by 10 matrix. Or since this 3 by 3 matrix, this plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, so I have assigned the signs. That's the first step, right? Now we're going to start with the first number there. That's +1, right? +1. Do I need to include the positive before we know it's a positive number? No, this +1, right? Now, you see this +1 is located at row 1, column 1. Alright, so since this number 1, right, +1, is located at the first row, first column. Now if I'm to obstruct that first row and first column, you notice I have a smaller 2 by 2 matrix that is 5, 6, 2, 4, right? So now we're going to find the determinant of that smaller matrix there. That's the right diagonal minus the left diagonal, right? So let's see, 5 times 4, right, that's 20. 5 times 4, 20, minus 6 times 2, right, that's 12. You understand? 20, that's 5 times 4, minus 6 times 2, so that's the smaller 2 by 2 matrix. Now that's for this positive one. The next number we're going to take into consideration is negative 2, right? Negative 2. Then in bracket, you see this negative 2 is located at row 1, column 2, right? Not column 3. Like that number there, 2 with the intersection of this first row with the second column. So if I'm to cover this first row and this second column, I don't know if you can see what we have there. We now have a smaller 2 by 2 matrix, that's 4, 6, 0, 4, right? A smaller 2 by 2 matrix, 4, 6, 0, 4. So I'm going to get the determinant of this smaller 2 by 2 matrix, multiply this diagonal, subtract this one, right? So 4 times 4, 16, right? Minus 6 times 0, right? 4 times 4, 16, minus 6 times 0, right? Then finally, we're going to look at this third number, positive 3, right? Positive 3. And now, this positive 3 is located at, row 1, column 3. That's the first row and the last column. So if I'm to cover the first row and the last column, where the 3 is located, I'm going to have a smaller 2 by 2 matrix, that is 4, 5, 0, 2, right? So I'm going to find the determinant of this smaller 2 by 2 matrix. That's 4 times 2, minus 5 times 0, right? So 4 times 2, 8, minus 5 times 0, that's 0, right? So I'm going to have 8 minus 0. I hope everything was, understandable. So let's solve what we have here. Now this positive one, right? Determinant of this positive one, that's just 1, right? 1 times 20 minus 12. 20 minus 12, that's 8, right? Minus 2, this minus 2 there. Then we have 16 minus 0, that's 16, right? Then finally we have positive 3, and then in the bracket we have 8 minus 0. And 8 minus 0 happens to be 8. Okay, so the determinant of D is going to be equal to 8 times 1, which is 8, then negative 2 times 16, that's negative 32, right? Okay, then positive 8 times 3, that's positive 24, right? So now let's sum up everything and get the determinant of D. Alright, so we have 8 minus 32 plus 24, right? So let's see, 8 minus 32, that's negative 24, right? 8 minus 32, that's negative 24. And now we have plus 24. So negative 24 plus 24, that's the same thing as saying 24 minus 24, right? Which is equal to 0. Okay, so the determinant of this matrix, D, is equal to 0. And now there is this type of matrix, I don't know if we talked about it in the introduction to matrix, this type of matrix called the singular matrix, right? Singular matrix. A matrix that has 0 as its determinant is known as a singular matrix, right? So, okay, so let's take this last example on this 3 by 3 matrix determinant. We have find the determinant of E, right? If E is equal to 1, 0, negative 2, 4, 3, 3, 1, 5, negative 7, right? Let's find the determinant of E. So the determinant of E is going to be this. 1, 0, negative 2, 4, 3, 3, 1, 5, negative 7. Okay, so we all know step 1, right? We assign signs to the top, the numbers at the top row, the first row, right? So plus, minus, plus, and so on, right? Plus, minus, plus. And then we take into consideration the first number, which in this case is still positive 1, right? Positive 1 times what we're going to have in the bracket, the determinant of a 2 by 2 matrix. And how are we going to get that 2 by 2 matrix? You see this one here? It's located at the first row. It's located at the intersection between the first row and the first column, right? Intersect at that position there, that's the 1. Right? So if I'm to obstruct, if I'm to cover the first row and the first column, I'm going to have 3, 3, 5, minus 7, right? 3, 3, 5, minus 7. So let's find the determinant of 3, 3, 5, minus 7. That 2 by 2 smaller matrix there. That determinant is going to be negative 7 times 3, right? Which is negative 21, right? Okay, and minus 5 times 3. Remember, negative 7 times 3 minus 5 times 3, which is 15. Okay, so that's for this first number. Now the second number, which is negative 0, is not like negative 0, because minus 0, right? Minus 0, then in brackets, we're going to have, if I obstruct the first row and the second column, I'm going to have 4, 3, 1, minus 7, right? So find the determinant of that 2 by 2 matrix. I'm going to have minus 7 times 4 minus 3 times 1, right? Negative 7 times 4 minus 1 times 3, right? Okay, so negative 7 times 4, that's negative 28, right? Then minus 3 times 1, that's 3. Okay, then finally we have plus negative 2, right? Plus negative 2. Plus and minus meeting, the resulting sign is going to be negative. So at the end of the day, we have negative 2 there. If we have something like negative there, that would be negative, negative 2, right? Negative, negative 2. That would result to positive 2. You understand? But since we have plus here, plus meeting minus results to minus as well. So we have negative 2 here. Then this number, negative 2, is located at the first row, last column, right? So if I'm to obstruct the first row and the last column, I'm going to have 4, 3, 1, 5, right? 4, 3, 1, 5. So the determinant of 4, 3, 1, 5, that's 4 times 5 minus 1 times 3, right? So 4 times 5 is 20, right? Minus 3 times 1, that's 3. So let's put everything together to finalize with the determinant of E. So this is 1 times what we're going to have in brackets, right? And now in the brackets we have negative 21, negative 15, which is going to result to negative 36, right? Negative 36. So 1 times negative 36 is negative 36, right? We're going to have minus 0. Then in brackets we have negative 28 minus 3. That's negative 31, right? Okay. Then here we have negative 2. Then multiplying 20 minus 3. That's 17, right? Okay, so let me just include the 1 here. So it's going to fill an on. Okay, so finally the determinant of E is going to be equal to 1 times negative 36, which is negative 36, right? Then minus 0 times negative 31. 0 times negative 31, that's 0, right? Then finally minus 2 times 17, that's 34, right? Minus 2 times 17, that's 34. Okay, so finally we're going to add up everything to get the determinant of E. Okay, therefore the determinant of E is going to be equal to minus 36 minus 0, still minus 36, right? Now minus 36 minus 34, that's negative 70. Negative 70, right? Minus 36 minus 0 minus 34, negative 70. So the determinant of this matrix E is equal to negative 70. Alright, so that will be the end of the topic, determinants of matrix. When next we meet, we're going to look at other aspects of matrix, right? Since I didn't give any classwork or any assignment or any work for you to practice with, it's now left with you to decide, if you're going to practice or not, which I advise you do, right? Practice on this so you're going to perfect your skills in mathematics. So now if you haven't subscribed to this channel, I don't know what you're waiting for. Please hit the subscribe button, like this video, and share it as well. So you're going to spread the knowledge. You know, Jam is by the side, by the corner. We need to get this knowledge out there, so people are going to know what to write if they are faced with this kind of question. So I'm going to see where